All right, so beginning with problem number 10. The spinner below is broken into congruent sectors. Round all answers to the nearest hundredth. Put your head up for me, dear. You need to pull your test review out, please. How many congruent sectors is the spinner broken into? 12. There are 12 pieces there. Part B, find the area of the entire spinner. What shape is the spinner? Circle. So we want the whole circle here. How do you find the area for a circle? Pi r squared. What is the radius of this circle? 33. So pi times 33 squared. Thank you. What is pi times 33 squared? Thank you. What is pi times 33 squared? Is that right? Did I write it down correctly? Okay. 3421.194, and then that would be centimeters squared. Part C says find the area of each sector. If I'm inspecting each sector, how many do I look at a time? 1. So this would be 1 out of how many? Out of 12. So if I'm inspecting each sector, that would be this right here. And so that fraction would be what? 1 over 12, 1/12. We're still talking about area, but now I'm not looking at the whole circle anymore, so I need the fraction of the circle that I'm looking at. But then I still need the area formula, pi r squared. 2 pi r would find a length of the crust, part of the arc length. 2 pi r will never find area. If you want area, you need to do pi r squared. The way I remember this is that when we find area, we always have squared units on our area. So the formula that has the r squared is the area formula. So for this one, my fraction is 1 over 12 times pi times the radius of 33 squared. What is 1/12 times pi times 33 squared? (285.1) or 0.099, depending on how you round that there. Centimeters squared. There's only one little piece that's different between parts C and part D. What is different in part D from part C? We're looking at 7 sectors. Will that affect my radius? No. What will that affect? The fraction. What will the fraction be now? 7 over 12. So area is still equal to fraction times pi r squared. So my area is 7 out of 12 times pi times 33 squared. What do we get when we do 7 out of 12 times pi times 33 squared? 0.7 or 0.696, 0.697. I'm not going to get picky. I rounded the last one to just one decimal place. I'm going to take this one out further. But if you write 1995.7, I would give you full credit for that. Yes, sir. Let me see what it shows. You did times 2 instead of squared. Multiplying by 2 is different than squaring. You've got to use this button here for squaring. All right, and that would be centimeters squared. I need you to put that away, please. All right. What else would you guys like to see? Got to keep your head all the way up. I need you to sit up with your head up off the desk, please. Number 9, absolutely we can do number 9. Number 9, do I have a whole circle here? I do not have a whole circle. We have to figure out what fraction of the circle we are looking at. Since I don't have the whole circle, I can't see how many pieces the whole circle has been chopped into. But every single circle that we know of has already been broken into 360 little parts, because every circle has 360 whats? 360 degrees. The degrees of a circle are a way of cutting it into little sectors. It cuts it into 360 little sectors. So if I don't see the whole circle and I can't tell how many pieces the circle has been cut into, I have to use the degrees to chop my circle up. How many degrees is this piece of circle? 110. So my fraction will be 110 out of what? Out of 360. Part A says we need to find the arc length. Arc length is equal to the fraction of the circle that we are looking at, not times pi r squared. Pi r squared finds area. This is times 2 pi r. So I have 110 out of 360 times 2 pi times, how big is the radius? 4.8. Notice the radius has nothing to do with the fraction. Not on this problem, not on the last problem. The radius only goes in for r. Radius has nothing to do with the fraction. So we do arc length, 110 over 360 times 2 pi times 4.8. And that gives us an arc length of what? .215. And that would be meters. Part B, now we're talking about area, not arc length. Area is equal to the fraction of the circle that we are interested in times pi r squared. I will give you the arc length and the area formulas, but it will not have the equals A and equals AL. You just get the part that's after the equal sign. You have to know which one goes to arc length, which one goes to area. What fraction of the circle are we looking at? 110 out of 360. So 110 over 360 times pi times our radius of 4.8 squared. And then we pop that into our calculator. We get what for the area? 22.117, and that would be meters squared. What else would you guys like to see from the review? Number 8? Absolutely. Let's go look at number 8. Sarah is the stage manager for Footlight Musicals. The stage is a trapezoid with an area of 102 square feet and bases of 10 feet and 15 feet. What is the height of the trapezoidal stage? So the first thing I need is my area formula for a trapezoid. So there's two mistakes, two common errors that I'm seeing when people are writing down the area formula for a trapezoid. We're doing a pretty good job of remembering the 1/2, but a lot of people are forgetting the height after that. Times base 1 plus base 2. So a lot of people just have 1/2 and then base 1 plus base 2. You need that other dimension. The bases go this way. We need the height that goes this way so that we get the entire area. So don't forget the height. The other mistake that I'm seeing that's pretty common is if we're remembering the height, then we're changing this to multiplication. The trapezoid area formula is the only area formula that has a plus sign in it. You have to add the two bases together, multiply that by the height, and cut that in half. All right, let's figure out what we've got. It says it has an area of 102 square feet. So that goes in the place of A. So 102 equals 1/2. Do we know the height? Then I just have to leave that as H. Do we know the bases? 10 and 15. So I can add the 10 and 15 together inside the parentheses. All right. So order of operations, first thing I have to do is simplify inside the parentheses. What do you get when you do 10 plus 15? 25. So I have 102 equals 1/2 H, and then inside the parentheses, 25. Well, what's half of 25? What? 12.5. So this would be 12.5 H. What operation is connecting the 12.5 and the H together? Multiplication. So how do I get rid of the 12.5? We're going to divide both sides by 12.5. And that will leave me with just the height. What do we get for our height? 8.16. What kind of units should we put with that? Feet. Beautiful. What else are we looking at? You said 11, and then which one? 13. So let's do 11, and then we'll do 13. Perfect. 11. It says hexagon ABCDEF is inscribed in circle G. Write down a specific segment, angle, arc for the following. Then find its measure if possible. A radius goes from where to where in a polygon? From the vertex to the center, yes. Need your head up for me, dear. We go from the vertex to the center. Do you guys see any segments that go from the vertex to the center on this hexagon? H, which one? Not HG, because that's not a vertex. AG, remember, vertex means corner. So you have to go from a corner. So AG would be one. Any others? BG. HG goes from the center, but it doesn't go to a corner, it goes to the side. What do we call it when it goes from the center to a side? The apothem. So HG would be the apothem here. Minor arc, we're going to go in between the two radii right here. So I can call that arc BA or AB. the measure of the minor arc will be the same as the central angle. So down here it talks about the central angle. Let's go ahead and name our central angle at the same time while we're here. So my central angle is formed by these two radii right here. What would that angle be called? BGA or AGB. So angle BGA, or again AGB. The measure of the central angle is same as the measure of my minor arc. How do we find the measure of the central angle? 360 divided by the number of sides. How many sides do we have here? 6 sides. What is 360 divided by 6? 60. So my central angle is 60 degrees, and my minor arc is also 60 degrees. The major arc, this will be all the rest of the circle, except for that minor arc. So here's my major arc. I can call that AFB, AEB, ADB, ACB, or we could go the other way around. We could call it BCA, BDA, BEA, or BFA. I'm going to call it BFA. I need to make sure that I have those endpoints, B and A, on either end, and then I need one of the points that's on the long way around the circle in the middle. That is an entire circle, 360, minus what? Minus 60, minus my minor arc. What is 360 minus 60? 300 degrees. All right, 2 more parts. We need the inscribed angle and then a congruent statement. An inscribed angle has its vertex on the circle. So this angle right here would be one example. Angle ABG. I could have done BAG. That would also be an inscribed angle. We want to find the measure of that inscribed angle. And to find the measure of the inscribed angle, I'm going to look at just half of this triangle that's formed by my central angle here. So half of what's formed by the 2 radii. I'm going to redraw that off to the side real quick. All right, so there's my triangle. This is H, this is B, and this is G. What's the angle at H? It's a right angle. How big is a right angle? This is 90 degrees. Right here at G, let's see, the whole central angle was 60 degrees, right? What's happening to that central angle right here? It's being cut in half. So we have 60 degrees cut in half, so that would be 30 degrees. So I have a 30-degree angle, I have a 90-degree angle. I know that all 3 angles in a triangle add up to how much? 180. So I can do 180 minus, and then I have to put the 90 and the 30 together. What is 90 plus 30? 120. So I have 180 minus 120, which would give us what? 60. Then it says, write a congruent statement for the 2 congruent triangles pictured in the figure. So one of those congruent triangles is the one that I highlighted in pink up here, BHG. Triangle BHG is congruent to triangle. So here's one of the triangles that's shown. This is the other triangle that's shown. So the pink one is one. The white one down here is the other one. What angle would be congruent to B? A. What angle would be congruent to H? H. And what angle would be congruent to G? So BHG is congruent to AHG. All right. And then 13 was the next one that I was asked for, so we'll go look at number 13 next. Give everybody a second to get this written down before I go to number 13. Yes. Yes. Do you have a Chromebook charger? Right. You can plug it in the back. Thank you. You're welcome. All right, let's go look at number 13 now. Here's number 13. It says find the area of the shaded region. I have two shapes going on here. What are those two shapes? I have a circle. And what's the other shape? Triangle. Which one is the whole? The circle is the whole? The triangle is the whole. The triangle has been cut out of the circle. It is the part that is not shaded. All right, so we're going to have to take the area of the circle minus the area of the whole, which is triangle shaped. How do we find area for a circle? Pi r squared. We have two different ways that we can find the area of a triangle. What's one of them? 1/2 base times height. What kind of relationship do the base and the height have to each other? And this is for any of my shapes, not just triangles. What kind of an angle do the base and the height have to form with each other? Has to form a 90-degree angle, right? The base and the height has to form a 90-degree angle. Now, the height doesn't have to be a side. But on this triangle, what type of triangle do we have here? I have a right triangle. I have two sides that are coming together and making that right angle. So one of them is the base and the other one is the height. What are those two sides? 6 and 8. So one of them I'm going to put in for the base. One of them I'm going to put in for the height. What is 1/2 times 6 times 8? 24. So it's circle minus 24. I just need to figure out the size of the circle here. We need to do pi r squared. That means I need the radius. Well, this is a radius, right? What do we call this whole thing here? That's the diameter. That's also one of the sides of my triangle, right? And I know that a diameter is formed with two congruent radii. So these two are the same size. So if I can find the diameter, I can cut it in half and I get the radius. What shape is the whole again? Triangle. What kind of triangle? Right triangle. What can I use with right triangles to find missing sides? Pythagorean theorem. A squared plus b squared equals c squared. What part of a right triangle has to go in for c? Hypotenuse. Do we know the hypotenuse of this right triangle? No, that is the diameter. So I'm actually going to replace c with diameter. So I have a squared plus b squared equals diameter squared. So what goes in for a and for b? 6 and 8. So I have 6 squared plus 8 squared. What is 6 squared? 36. 8 squared is 64. So 36 plus 64 equals diameter squared. What is 36 plus 64? 100 equals diameter squared. I don't want the diameter to be squared, though. I want just the diameter. So what do? Square root. If you do it to one side, got to do it to the other side. So the squared and square root cancel out over on the diameter. What is the square root of 100? 10 is equal to the diameter. So this is 10. Well, if the diameter is 10, how big's the radius? 5. This one's 5. This one's 5. So pi times 5 squared. What is pi times 5 squared? 78.539. And from that, we need to subtract 24. What do we get? 54.539. Should we put units with that? Centimeters squared, yes. All right, we have time for about 3 more questions. What would you guys like to see? Number 12? Absolutely, we can do number 12. Number 12, I have a triangle here. So for a triangle, area for a triangle is either 1/2 base times height. We wrote that one down already. Or we had another area formula for a triangle. What was the other area formula? 1/2 AB times the sine of angle C. If I don't know the base and I don't know the height, but I do know 2 sides of the triangle and the angle in between them, then I can use that second area formula. Do we know the height of this triangle? Do I have the ability to find the height of that triangle? Not with the information given. I don't have enough. So I'm not going to be able to use this formula. We're going to have to use this one. So A and B are going to be sides. And C is the angle between those 2 sides. Do we have at least 2 sides on this triangle? How big are those 2 sides? 18 and 26. So I'm going to put 18 in for one. I'm going to put 26 in for the other. And then I need the angle in between those 2 sides. Do I have the angle that's between those 2 sides, that touches those 2 sides? No, that's this angle right here. Do I have the ability to find it? Yes, I do. 180 minus, and then we're going to put those other 2 angles together. 74 plus 44. What is 74 plus 44? 118. So I have 180 minus 118, which gives us 62. So this angle here is 62 degrees. So 1/2 times 18 times 26 times the sine of 62 degrees. Make sure that the calculator is in degrees mode before you put this into your calculator. Up at the very tippy top, it should either have a letter D or DEG, depending on the kind of calculator you're looking at. But if it is not in degrees mode, it won't give you the right answer. Yep, 206.61. And that would be feet squared. All right. Time for about 2 more. What else would you guys like to see? 14 part D. And which one did you say? 14 also. Let's do 14 part D. This one reminds me a lot of the problem that we had on the skills check. Very similar looking shape. So one of the things you have to be careful about, like I very clearly see the triangle on here. But then I have this L shape. that I'm going to have to cut into what types of shapes? I'm going to have to cut it into rectangles. Now, when you cut up an L shape into rectangles, it's really important that you mark on there how you're cutting it. Because what I had happen yesterday on the skills check for quite a few people was they cut it this way and they found the area of this rectangle. But then for the other part, they cut it this way and they found the area of this rectangle. And they added those together, which means this little section up here got added in twice because it got counted as part of both rectangles. You don't want to add the same piece twice. So you have to draw in how you're cutting it. I'm going to go ahead and cut it like this. You guys okay with that? When I cut it like that, I see I have 2 rectangles that I need the area of, and I have 1 triangle. So to find the area of a rectangle, we do length times width. For the other one, we'll do length times width. And for the triangle, should we do that 1/2 AB sine C? No, I don't know 2 of the sides, and I don't know any of the angles. So I'm going to have to do 1/2 base times height. Please don't forget on the triangle to put the 1/2 there. If you don't put a 1/2 there, you're finding the area of a parallelogram, not a triangle. You have to have the 1/2 for it to be a triangle. All right, let's do this top rectangle. That is what by what? I heard 9 by 2. When you look over here, this entire side is 6 feet. We know from right here that this much is 4. So that means this much right here would have to be 2, so that together that makes 6. So length times width, I've got 9 times 2. What is 9 times 2? 18. So I have 18 plus. Now I'm going to move on to my other rectangle. This other rectangle is what by what? 4 by 4. So technically this is a square, right? So I could do 4 squared. What is 4 squared? 16. So I have 18 plus 16 plus, and now I got to look at this triangle, 1/2 times the base times the height. The base has to be a side of the triangle. Do I know how big this side is? No. Do I know how big this side is? Also no. Do I have the ability to figure out how big this side is? Yes. I know this is a square. The bottom of the square is how big? On the square? 4. So the top of the square would be 4. So that little dashed line that I have right here is 4 feet. But across the entire top is how much? Across the entire top is 9 feet. Well, if this much is 4, how much do I have left for the triangle? I have 5 feet here. So my base is 5. Times the height. Well, the height of the triangle would go from the base to the vertex. That's the same as this right here. So 4. So 1/2 times 5 times 4. What is 5 times 4? 20. What's half of that? 10. So I do 18 plus 16 plus 10, and I get what? 44. So we have 44 feet squared. I have time for one more, I think. Yes. 14A? Absolutely, we can do 14A. What 2 shapes have been put together? Not a triangle. Trapezoid. I want to look at this entire shape up on the top. I know I could split that up into 2 triangles and a rectangle in between, but it's easier to look at it as a trapezoid. So we have a trapezoid here. Together, what operation do we use to put things together? Addition. So trapezoid plus this guy down here, which is a rectangle. If there's a hole, we subtract. So if I have a piece on my shape that's the same color as the paper, I'm going to subtract it out. If it's pieces that have been put together, stacked on each other, then we're going to add them together. So I need the area of the trapezoid plus the area of the rectangle. To find the area of a trapezoid, we do 1/2 height times base 1 plus base 2. And for the rectangle, we do length times width. So let's look at our trapezoid first. Do we have the height of the trapezoid? How big is the height? 4 inches right here. There's my height. So 1/2 times 4. Do we have base 1? How big is base 1? 13. Do we know how big base 2 is? 24. We know that this side right here is 24. So that means this right here would also be 24. So that's base 2. All right, let's do just that part. 1/2 times 4 times 13 plus 24. $74. All right, now we have our rectangle. That's this guy right here. I need length times width. What's the length? 24. Times the width. What's the width? 11, because this entire thing top to bottom is 15, right? And we know that the trapezoid from here to right here is 4. So this much right here would have to be 15 minus 4, which would give me 11. So 24 times 11. How much? 264. 74 plus 264 would give us what? 338 inches squared. Very nicely done. All right. I don't have enough time to go over any more questions, but I do want to talk to you about the answer key and also the videos, because some of the other problems that I have gone over in other classes, I've gone over all of number 1. I've gone over number 3, part B, and number 4, number 5, and number 6. I think we did 8. And then I know I've also gone over number 14, part C. So if you watch the videos, you can get those particular pieces as well. On today's Canvas page, if you look at Tuesday 422 and you scroll all the way to the very, very, very bottom, this is where the Module 11A Review Solutions can be found. If you click on this, it will open up a PDF that has all of my work for all of the problems on there. Around lunchtime today, the first 2 videos will go up for first and second period. By the end of the day, the third and 7th period videos will go up. Again, these will be great places to look, looking at first, second, and 7th to help you with some of the problems that we did not have time to go over in this class. You will be turning in your test review tomorrow when you come in to take the test.